Hey math enthusiast, I'm here to go over this geometry reasoning practice problem. So I'm given this graph below and I want to start off by sketching points A and B on my graph. Now what I'm looking for is the location of point C so that I can form triangle ABC with an area of 20 square units. So let's plot P somewhere and see what happens. I'm going to choose to put C right here at 2, 3. Now I've formed triangle ABC, but the question is, does that actually have an area of 20 square units? Okay, so first I want to think about how can I calculate the area of a triangle. So in order to find the area of a triangle, it is 1/2 base times height. So it looks like after I plotted point C at 2, 3, my base down here is 2 units, and my height up here is going from 3 to 7. Looks like it's 4 total units. Now, if I were to plug that into my formula here for the area of a triangle, I'm going to end up with 1/2 2 times 4. So if I were to simplify this, I would end up with 1/2 times 8. Half times 8, or you could think about it as 8 divided by 2, is going to equal 4. So I end up with 4 square units, which is not equal to the 20 that I need. So let's think about approaching this problem a different way. Instead of starting with the graph, let's start with the formula. So in my formula, they told me specifically that my area has to equal 20. So let's replace our area, or our A, with 20. Now after that, I know my area is equal to 1/2 base times height. Well, A and B are going to stay where they're at on this graph. So my height, regardless of where C is always going to be 4. So I'm going to put that inside my formula. So we have 1/2 base times 4. Now I'm not positive what my base is going to be because that's really going to depend on where C is on my graph. Let's see if we can simplify this formula a little bit. Well, 1/2 times 4, or you could think about it as 4 divided by 2, is going to equal 2. Now, the next thing I want to do is I want to get B all by itself because I'm trying to figure out what would the base have to equal for my area to be 20. So next what I'm going to do is I'm going to divide by 2. Once I simplify that, it looks like my base is going to have to be 10 units. Now we can go back to our graph. So I know that point C is going to have to be 10 units away from this side of my triangle in order to create that base of 10 units. So that means I can put point C 10 units to the right here. So this would form my triangle ABC with an area of 20. Now the thing is, that's not the only location. For example, I could put point C up above here, right across from B. This would also form my green triangle, would have an area of 20 square units. Or I could actually put point C right in the middle here. Now that's still 10 units away from my base here, and now my triangle would be this black isosceles triangle. So we have a ton of different options. All right, because I could also have C in between these points. So it looks like as long as C is 10 units away from my base, then it's going to give me the area I'm looking for. So it looks like point C could actually be anywhere along this line right here. Any of these points on this line, because they're all going to give me a base of 10. Which is therefore going to give me my area of 20. Now, That's only half of it, because technically I could put C over here inside the second quadrant. Okay, so I could reflect it over and I could have C here at negative 10, 3, or C here at negative 10, 7, or anywhere in the middle, or technically any of the points along this vertical line. All right, so notice that each of these lines are 10 units from the base of the triangle that they started me with. All right, and if you notice, they are actually parallel to one another as well. Now, the formula for these lines, since they're vertical lines going through specific points, negative 10 and 10, the formula for this line on the left is going to be x equals negative 10, because all the x coordinates here are negative 10. And then on the right, this one is obviously going to be x equals positive 10, because all the x coordinates here are positive 10. So now the question becomes, how can I enter all this information into an online test so that I can specifically answer part B of this question? Let's take a look. So now I'm viewing my CRT practice problem on Linkit. So it's the same problem with point A, point B. I'm looking for the location of C, and it has to have that specific area. So essentially what I want to do is copy down everything that I wrote earlier into this response area. So let's start with our graph. So I want to include all the information that I wrote down earlier. So I'm going to click here to edit my graph. First thing I want to do is sketch out my points. So right now I have the pencil option. I know my first point was at 3, 0, so that was point A. So I'm going to sketch that out. I'm going to label it as point A. Your other option, if you want something a little bit neater, is to use these little circles. So point B was at 7, 0. So I'm going to put a little dot there. And if you don't feel like writing, you can always include a text box. Open my text box and then type in capital B. So they're not matching, but that's all right. It's understood that that is point A and B on my graph. Last thing I want to do is just connect them, because technically they are endpoints for a segment. So last thing I want to do is try to figure out where point C was located. So we already did that earlier, and I know that I had several different locations for point C. The first one I found was at 10, 3. After that, we determined it was at 10, 7, and I pretty much figured out that it was all the points along this vertical line. So I'm going to go back to the line feature, and I'm going to draw my vertical line going through all those points to show, okay, C can be anywhere on this vertical line. But I want to show that it continues above and below my graph. So I'm going to add little arrowheads using the pencil feature. Now, that was only half of it. My other options were on the other side, where this line, this vertical line, x equals negative 10. So we'll sketch that out using the line feature. I'm going to jump back to my pencil again, just to show that this is a line. It does go on forever. So I want to include those arrowheads. Okay, so I think my graph is done. So now I've displayed all the possible locations for point C, but I want to make sure that the grader understands what I've shown in the graph. So first I'm going to submit my answer by clicking this green check mark. And I'm going to enter some information down here below. So first thing I knew was that the area was equal to 20 square units. After that, I used the formula for the area of a triangle. And that was equal to 1/2 base times height. Now, in case your reader doesn't understand, we can specify B is for base and H is for height. Following that, I want to type in here the work that I wrote down earlier. So what we did was I plugged in 20 for my area in my equation. We had 1/2. I was trying to solve for the base, but I knew that the height was 4 units. After that, we simplified our formula. So we had 20 equals 2b. And finally, I found out that 10 equals b. Or you could say b equals 10. After that, I wanted to specify where exactly C could be located. So we'll put down locations for point C. And that would be on the line x equals 10 and x equals -10. So that provides all my possible solutions for this problem. I've shown the equations or formulas that I've used here. Formula for the area of a triangle. I have the equations for my vertical lines where C can be located. So at this point, I can just make sure that my final answer is submitted. So I'm just going to click this right arrow just to save my answer and go on. Now there is no next question, so at this point I can submit what I've completed.